Okay, so here are the problems 10 through 15. So 10 is the equation on the board here. And so what we'll do is we will find the possible rational zeros. So we're going to have 8. So the factors of 8 are 1, 2, 4, and 8. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And that's because the coefficient in front of x cubed is 1, so we don't have to worry about that. So let's start at 1. So we do our coefficients associated with the equation. We'll put x equals 1 in there. Bring 1 down. 1 times 1 is 1. Negative 1 plus 1 is 0. 1 times 0 is 0. Negative 10 plus 0 is negative 10. 1 times negative 10 is negative 10. Add these together, you get 18. So that says f of 1 is negative 18. Okay, so that is not a 0. So let's try 2. We could have also tried negative 1, gone the other direction, see what happens. Okay, bring that down. 2 times 1 is 2. Negative 1 plus 2 is 1. 2 times 1 is 2. Negative 10 plus 2 is negative 8. 2 times negative 8 is negative 16. So that's negative 24. So we're going the opposite direction we want to go. So let's try negative 1. Okay, bring the 1 down. Negative 1 times negative 1 is negative 1. Add these together, we get negative 2. And negative 1 times negative 2 is positive 2. Negative 10 plus 2 is negative 8. Negative 1 times negative 8 is positive 8. And you add this together, you get 0. Let's double check, make sure we did this right before we claim victory. So bring that down. Negative 1 times 1 is negative 1. Negative 1 plus negative 1 is negative 2. Negative 1 times negative 2 is positive 2. Negative 10 plus 2 is negative 8. Negative 8 times negative 1 is positive 8. And that looks like it's going to work. So what we can say is x equals negative 1 is a 0. And x plus 1 is a factor. We can also say that what we have left over is this quadratic equation. X squared minus 2x minus 8. And if we're lucky, we can factor that, which we can. If we couldn't, if it didn't jump out at us, then we could use the quadratic formula or completing the square. So what two numbers multiplied together give us 8, whose difference is 2? And the answer is 4 and 2. So it's going to be 4 and 2. And one's going to be positive and one's going to be negative. We have a negative 2 in the middle, so we need to put the negative with the bigger part and the positive with the smaller part, so that the net result is a negative. And you can see we get the right answer. You get x times x is x squared. You get negative 4x plus 2x is negative 2x, and negative 4 times 4. So now we have that x equals 4 and x equals negative 2 are zeros, and x minus 4 and x plus 2 are factors. So what that allows us to do is we can rewrite the original equation in terms of the factored form. So we got x plus 1 from there, from the first guess, and x minus 4 and x plus 2. Okay, so we've got 3 zeros and we've got the y-intercept is setting x equal to 0. That's f of 0. And that's equal to negative 8. This number right there. So now we can plot this thing. At least we can plot the x-intercept. So we've got a 0 of negative 1. Let's go from negative 10 to positive 10 here. So we got a 0 of negative 1. We got a 0 of negative 2. And a 0 of positive 4. Now, the end behavior says that it's going to come from down here, and it's going to go up through these 2 points, and it can't go too far because the points are close together, so there's not room to go. And the y-intercept is negative 8, so let's go from positive 10 to negative 10 on this scale. So negative 8 would be right here. So this thing's going to come down, and then it's going to loop back this way, and then back up. So that's kind of the way that one works out. Okay, next problem. F of x equals x cubed plus 11x squared plus 23x minus 35. So the possible rational zeros are the factors of 35 divided by the factors of 1. So factors of 35 are 1 and 35 and 5 and 7. So our possible rational zeros are plus or minus 1, plus or minus 5, plus or minus 7, and plus or minus 35. That, just from experience, they're unlikely to be plus or minus 35. So let's do what we just did before. We're going to start at 1, see what we get, then we'll try 5, and then look at the numbers. If neither one of those is 0, then we'll decide whether we want to go to 7 or to negative 1, which way we're going to go. Okay, so 1 comes down. 1 times 1 is 1. 11 plus 1 is 12. 1 times 12 is 12. Add these together, you get 35. 1 times 35 is 35. Negative 35 plus 35 is 0. So what we can say is 0 is x equals 1. The corresponding factor is x minus 1. And what we're left with is, according to these coefficients, x squared plus 12x plus 35. And what we want to do is we want to factor that if we can. Are there two numbers multiplied together to give you 35 that add up to 12? And the answer is yes. They are 5 and 7. This is why it's good to know your multiplication tables. So 5, 7. Now because this is positive and this is positive, then these have to both be positive. So what that says is we have two factors. We have factor x plus 5, x plus 7, and we have zeros of x equals negative 5, x equals negative 7. So our original function here can be written in terms of the factored form, x minus 1 times x plus 5 times x plus 7. So this equation is that. And we can also find the y-intercept. That's f of 0. So we go over to this form the unfactored form and look for the constant, which is negative 35. And remember the corresponding zeros here, x equals 1, x equals negative 5, and x equals negative 7. So if we take a piece of graph paper, and you can see with this y-intercept of negative 35, we're probably going to make the scale much larger in the y direction than we did last time. So let's go from 100 to negative 100. So we have an x-intercept of negative 7, it's right there, an x-intercept of negative 5, and an x-intercept of 1, and a y-intercept of negative 35, so 10, 20, 30, 35. So again, the end behavior is going to have the function coming up like this. It's going to loop around, and then it's going to come down here, probably something like this, and then go up like that. And we could check this out if we wanted to use a graphing program. But the key thing I'm looking for is the end behavior, the y-intercept, and the x-intercepts. We'll worry about these points when we get to calculus. Okay, next problem. X cubed plus 3x squared minus 4x minus 12. Okay, so the factors of 12, let's just do the factors of 12. It's 1 and 12, 2 and 6, 3 and 4. So we have our possible rational zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, and plus or minus 12, or 6, and plus or minus 12. So we got quite a few possible rational zeros. Now, if it was 12, then the other remaining one factor is 12. The others have to be 1. So again, it probably makes sense to start at x equals 1. See what we get. So let's pick x equals 1. Bring this 1 down. 1 times 1 is 1. 3 plus 1 is 4. 4 times 1 is 4. Negative 4 plus 4 is 0. 1 times 0 is 0. Negative 12. Okay, so that one didn't work. So let's go to positive, the next positive one, which is 2. So put 2 in here. So bring this down. 1. 2 times 1 is 2. 3 plus 2 is 5. 2 times 5 is 10. Negative 4 plus 10 is 6. 2 times 6 is 12. 0. Bingo. So what we can say is our 0 is x equals 2, and our factor is x minus 2. And what we have left over is this quadratic, x squared plus 5x plus 6. Two numbers multiplied together give you 6, added together give you 5, 2 and 3. So that's the two remaining factors. So we have the factors of x plus 2 and x plus 3, and we have the zeros. So let's go ahead and put all the factors. So we also get x minus 2. And the zeros are x equals negative 2, x equals negative 3, and x equals positive 2 from these three factors. And if we go back to the original equation, we can get the y-intercept. That's f of 0 and that's negative 12. So we will get a piece of graph paper. So we'll go from negative 10 to positive 10. We'll go from 20 to 20 because our y-intercept is negative 12. So let's see, we've got a 0 at negative 3, 0 at negative 2, and a 0 at positive 2. And the y-intercept is negative 12. So each one of these grid marks is 2 units. So it's 2, 4, 6, 8, 10, 12. So again, the function is going to come up here from negative infinity. It's going to loop around. This is about halfway between, so it's probably going to be pretty close to there. Maybe not exactly through that point, but it's close. So there we go. That's what it looks like. Okay, we've got f of x. Is x cubed plus 4x squared minus 9x minus 36. So the possible rational zeros are the factors of 36, which are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, and then we've got plus or minus 6. So those are the lower half, and then we have the other corresponding numbers that are the other half of those. So 6 times 6 is 36. 4 times 9 is 36. 3 times 12 is 36. 2 times 18 is 36. And 31 times 36 is 36. So those are the possible rational zeros for this. So again, we're going to try x equals 1. Let's try 1. So bring the 1 down. 1 times 1 is 1. 4 plus 1 is 5. 1 times 5 is 5. Negative 9 plus 5 is negative 4. 1 times negative 4 is negative 4. And yeah, those two together, you get negative 40. Okay, so let's try 2. Bring the 1 down. 2 times 1 is 2. 4 plus 2 is 6. 2 times 6 is 12. 12 minus 9 is 3. 2 times 3 is 6. So that's negative 30. So we're going the right direction. So let's try 3. Bring the 1 down. 3 times 1 is 3. 4 plus 3 is 7. 21. 21 minus 9 is 12. 3 times 12 is 36. 36 plus negative 36 is 0. So there we go. We got that. So based on that, we know we have a 0 of x equals 3, and we have a factor of x minus 3. We also have this remaining quadratic equation. And we ask what two numbers multiplied together give us 12, added together give us 7. The answer is 3 and 4. 3 plus 4 is 7. 3 times 4 is 12. They're both positive. So from that, now we have the remaining two factors. So we have x plus 3. We have x plus 4, and we have x minus 3. And then we have the zeros. So this corresponding 0 is negative 3, negative 4, and positive 3. And we also have a y-intercept. Go back to our original equation of, that's f of 0, negative 36. So if we get our graph paper out, we'll go from negative 10 to positive 10 on the x-axis, and we'll go from negative 100 to positive 100 here. So here's our zeros: negative 4, negative 3, positive 3. The y-intercept is negative 36, so 1, 2, 3, 36. The function is going to come up here like that, come back around, go somewhere around there, and back up. Okay. The last two are the case where I'm going to give you a simple complex 0, and then you have to figure out the other complex 0 and then the remaining factors. Now this doesn't require any guessing, it just requires you to go through this procedure. So we have f of x is equal to x to the 4th plus x cubed plus 7x squared plus 9x minus 18. And one of the zeros is 3i. Now the corresponding factor is going to be x minus 3i. And the second factor, complex factor, is negative 3i. Because if you remember, we had complex numbers which are a plus bi. So that was the original. The complex conjugate is a minus bi. So you change the sign of the complex part. Now there is no real part, or it's 0. You know, both of these cases, a is 0. So plus, whether you just have 0 here, so you just drop it out. But you can see here it's plus 3i, corresponding complex conjugate. So from a factor standpoint here, instead of x minus 3i, when we have negative, you get x minus negative 3i, which is the same as x plus 3i. And then what you do is you take those two factors and you multiply them together. Like that. So we use FOIL. So first is we get x squared. Outer we get plus 3xi. So you put the constant first, the variable second, and the imaginary number last. So 3xi, and then in the inside we get negative 3xi. And then we get a negative times a negative, so it's negative 3i squared. 3i times 3i. Well, these cancel out, and we get negative 3 squared, so we're going to square 3, so that's 9. 9i squared. But remember, I squared is negative 1. That's because I equals the square root of negative 1, so I squared is negative 1. So that finally comes out to be x squared plus 9. You always end up with the plus. If you ended up with a negative, you could factor it. So if you have x squared plus 9, you can't factor that and get real numbers. So now what we could do is we know that these two factors multiplied together give us this quadratic. And what we're going to do is we're going to take the original polynomial and we're going to divide by that polynomial. And because we're dividing a fourth order polynomial by a second order polynomial, we'll end up with a second order polynomial, which hopefully we can factor. Which we can in this case because I made up the problem myself and then double checked. So this is our long division process. Now we can't use synthetic division because I've got x squared. So we have to use long division. Okay, what number multiplied by x squared gives us x to the fourth? So the answer is x squared. Now we'll multiply x squared by both terms. So x squared times x squared is x to the fourth, and x squared times 9 is 9x squared. And we're going to subtract that from the original polynomial. So this goes to 0. We'll bring this down, x cubed, and here we have 7x squared minus 9x, so that's going to be negative 2x squared. And let's bring the 9x down here while we're at it. Okay. Now we ask the question, what do I need to multiply x squared by to get x cubed? Well, the answer is plus x. X times x squared is x cubed. That's what I'm looking for. There is no x squared term. And then x times 9, so it's plus 9x. And then I subtract these. So x cubed minus x cubed is 0. Bring this thing down. 9x minus 9x is 0. So this goes to 0. And then I bring down the negative 18 for the next step. Okay, so what number do I multiply x squared by to get negative 2x squared? Negative 2. So I get negative 2, multiply negative 2 times x squared, I get negative 2x squared, multiply negative 2 times 9, I get negative 18. I'm going to subtract those, and I'll get 0. So that means that this gives me this result with no remainder. So I look at this equation, x squared plus x minus 2, and see if I can figure out how to factor that, which I can. Again, if I couldn't do it by just looking at these things, I could use the quadratic formula. But, you know, what two numbers multiplied together give me 2, but subtracted give me 1? Well, in this case, it's pretty simple. It's going to be 2 times 1 gives you 2. One part has to be negative, one part has to be positive. Because the intermediate term is positive, I'm going to put the positive with the bigger term and negative with the smaller term. So those are the two remaining factors. So what I can do is I can rewrite the original function where I was given just one complex 0, and it's going to be equal to x squared. Well, actually, it's going to be x minus 3i times x plus 3i, which gives me this x squared plus 9. And then the remaining two factors, the remaining real factors. So what this means is this fourth order polynomial is going to have two x-intercepts. These say there's not 4. You'd have to have 4 real zeros or 4 real factors to have 4 intercepts. So we have 2 intercepts. This doesn't really tell me anything about how the graph is going to look. And I didn't ask you to plot it. So final one, similar kind of thing. Here's the function. I'm going to give you one complex or one imaginary. It's both, because it's imaginary because it's the one term that just involves I, and it's complex because complex can be real plus imaginary or real or imaginary. It doesn't give you one of those three. Okay. Again, I don't have to guess anything here. I know 1, 0 is going to be x minus 5i. So that means the other 0 is x is equal to positive 5i. And the corresponding factors are x. You take the negative of that, so the corresponding factor for that is x plus 5i, and I get x minus 5i. Now if I multiply those two factors together, I'm going to get x squared. The inside and outside cancel out. I get 5xi and minus 5xi and plus 5xi. So negative comes from outside, and positive comes from inside. Then I get negative 25, so that's negative 5 times positive 5, I squared. These cancel out because they're the same but opposite signs. And I squared is negative 1, so I get negative 25 times negative 1, so I get x squared plus 25. So that's my quadratic term. And then I'm going to use long division to find out what quadratic I've got left over after I do the division. And again, I did these problems, so I know what the answers are. Okay, so what number do I need to multiply x squared by to get x to the fourth? That's x squared, same answer as last time. Then we take x squared times x squared, that's x to the fourth. X squared times 25 is 25x squared. There's no x cubed term in this row, and I subtract both of them. So this minus that is 0. I'll bring down the cube term from the original equation. 29 minus 25 is plus 4. Let's get plus 4x squared. And then I'll bring down 125x. Okay, next, what do I need to multiply x squared by to get 5x cubed? So the answer is 5x. 5x times x squared is 5x cubed. We don't have an x squared term. 5 times x times 25 is 125x. And we're going to subtract both of those terms. So 5x cubed minus 5x cubed is 0. Bring this number down, 4x squared. 125x minus 125 is 0. And we'll bring down the 100 from the original equation. And then finally, what do I need to multiply x squared by to get 4x squared? The answer is 4. 4 times x squared is 4x squared. There's no x term. Then 4 times 25 is 100. I subtract both terms. I've got 0. So I can take the equation here, x squared plus 5x plus 4, and see if I can factor that, which I can. Well, two numbers multiplied together equal 4 and added together equal 5. 1 and 4. And because this is positive and it's greater than 4, it's going to be plus. So from this, we know that we have a 0 of x equals negative 4 and x equals negative 1, and we have the factors. So what we can do now is we can put all of it together. X to the fourth plus 5x cubed. This is the original equation. 29x squared plus 125x plus 100 is equal to. Okay, so what were our complex roots? X plus or minus 5i. So x plus 5i, x minus 5i, and then these two, x plus 4 and x plus 1. And that's your final answer. If we multiplied this out, we'd get back to the original equation.